Air conditioners are incredibly power hungry and require a substantial amount of power to operate in a mobile, marine, or off-grid electrical system. But unlike electric space heaters like we talked about back in lesson 2.5 of this academy, air conditioners are typically more needed, one, during the summer when days are longer and there's more solar recharging power available, and two, during the daylight hours, again, where more solar recharging power is available. This means that if you have enough rooftop real estate on your van, RV, or boat, or enough solar panels next to your off-grid cabin, you can potentially run air conditioning. Let's start by talking about how much power air conditioners actually use so that we can make informed decisions. And that's exactly what I'm going to teach you here in lesson number 6 of this electrical system sizing playlist. My name is Nate, and welcome to the explorist.life Mobile, Marine, and Off-Grid Electrical Academy. Now, the methods of estimating power usage I'm going to teach you in this video will work for many different types of air conditioners. So, if you keep an open mind and think critically, you'll be able to apply this information to your own specific project and the air conditioner that you've chosen to use. Last thing before we get started, I put some important information about this academy, some additional resources, and some prerequisite information related to this video down in the pinned comment below, so be sure to scroll down and check it out. Let's get started. How much power does an air conditioner use? Since off-grid air conditioning is such a huge investment, I think it's really important for us to take a step back and dive deeper into air conditioner duty cycles, sizing, and efficiency. So I've actually interviewed 3 industry experts in residential and commercial heating and air conditioning to provide some additional insight into these considerations so we can all make informed decisions. So for everybody watching, we've got my 3 cousins, William there in the back, Tucker there on the left, and Colby there on the right. And they are the and Sons part of Yarbrough and Sons Heating and Air Conditioning out of Blanchard, Oklahoma. How's it going, guys?
Good.
Going great.
Good to see you.
Yeah.
Welcome to the Explorers Life YouTube channel.
Hey, happy to be here.
Hey, yeah. This is fun. I'm having fun.
This is a goal achieved. Bucket list.
So we have Yarbrough and Sons Heating and Air Conditioning is a family business. So Will Colby and Tucker's dad, Darren, started the business back in 1988, which was 35 years ago, which I've got that committed to memory because that was the same year I was born. We've all worked in Yarbrough and Sons to some degree. All 4 of us worked there growing up, provided some child labor there for many years. Those 3 moved off to college. I moved off to college. I didn't come back. Those 3 came back, and they are still there. So that's what's going on. Residential and commercial heating and air conditioning. So guys, the very first question that I have for y'all, how many air conditioners on RVs, boats, or off-grid cabins have y'all installed?
Oh, gosh. Within a year?
Ever.
Oh,
Okay,
gosh.
yeah.
It doesn't matter.
I think the answer remains the same.
I know.
I think so too.
I'm just messing with people.
Really none
Yeah.
for us.
Yeah.
Mostly because when it comes to cost efficiency of labor, for our guys and our technicians, it's not worth our time really to go out and do that type of work. So we punt it. There's a RV shop down the road that does all that for us. So we refer out to them quite a bit.
We do get asked a lot if we do RVs. And, yeah. But we don't do it. Yeah. So we punt it out.
So off-grid electrical systems aren't really your specialty necessarily. There's not a whole lot of off-grid systems there in central Oklahoma for the most part. But the concepts of off-grid versus on-grid air conditioning are going to be the same from a power consumption standpoint. You just may have to pay attention to your power usage when off-grid because you only have a finite amount of power. So that said, you guys are super, super experienced with air conditioning systems in general. So, on the flip side, how many air conditioning systems have you installed in the last 35 years?
Tens of thousands.
Tens of
Well,
thousands.
seeing that I'm only 31,
I don't know. So in any given year, we'll install around 700 to 1,250, just depending on like what commercial projects or anything
Yeah.
like that we have going on.
Yeah.
yeah.
And so
Now
now,
that some houses have more than one unit,
Yep.
and so it might be on one PO, but
Yeah. And to give it a little bit of a context, we're 2024 we're a 52 person team.
Yeah.
And so we've got install crews, service teams. We just added plumbing as well. And so for account, so what I do specifically is residential advising. I talk to homeowners every day, and I installed my PO list of how many jobs I did last year was like 120, close to it. Yeah. So about 120 separate residential systems installed just on my side.
Yeah, so we're talking, what, thousands or tens of thousands? I think I personally installed probably 1,000 in between the ages of 9 and 17. At least that's how I remember it.
For the government, it was between the ages of 17 and 19.
Yes.
Got it?
Yes.
Yeah, exactly.
But yeah, you're correct though. An air conditioner is an air conditioner. It doesn't matter the application, whether it's in a home, in a commercial space, in a camper, a boat, off grid, wherever. The whole goal is we're removing heat and trying to dehumidify a space.
Mm-hmm. And then vice versa during the winter.
You guys will be able to speak more on this to a degree, and we'll kind of cover this later in more depth. But a window unit air conditioner is going to take way less power than a big package unit that sits up on top of an industrial facility. And so, the goal of this video is teaching people how to find out how much power their air conditioner uses, their chosen air conditioner, and then be able to extrapolate, how much power they can actually see being pulled from their batteries on a day-to-day situation. Okay, so I've got a couple questions for you guys that I've kind of given you ahead of time so you can prepare some good answers for everybody watching. And Tucker, we're actually going to start with a question for you, and we're starting with Tucker because Tucker was actually subscriber number 1 to the Explorist Life YouTube channel way back in 2016 or 2017. Adventure in a Backpack back in the day. So you get to go first.
I don't know if it wins me any awards, but it makes me feel like I should get a best cousin in the tally. That's what I'm going for.
Hey, we're racing because I did provide the music for that first video. So
it doesn't matter.
And everybody hated it.
Mate, I'm just slacking, man. I got nothing.
Yeah.
I bring enthusiasm.
Yeah, so the first question that I've got for Tucker is, can you explain what a duty cycle is, what it does, and how it affects power consumption?
Yeah, absolutely. So a duty cycle, just kind of put in simpler terms, is how long an air conditioner is going to be running to fulfill your set temperature. So if you have your thermostat set at 68 degrees, how long is it going to take to cool you down to 68? And so a duty cycle is going to be anywhere between, half an hour to an hour, depending on where you're at, level of insulation, and things like that. So having a specific answer of how long a duty cycle should or shouldn't be is really contingent upon how much insulation you have, what the outdoor ambient temperature is, and what your thermostat is set at. If you allow me to have kind of those 3 variables known, then we can start answering some deeper questions. But, the longer an air conditioner runs, obviously, the more power it's consuming. And for off-grid systems, with most of them being self-contained, meaning you've got the condenser, the compressor, the blower motor, the evaporator coil, all in one unit, you don't have a split system like we do in houses, you're going to be able to find what's called the run load amps on the packaging. And somewhere on that data plate, it'll tell you what the run load amps of that system is. And whenever we get the run load amps of that system, well, now we can calculate our watts. And so we know how many volts we're running off of, and I don't know what an off-grid air conditioner will even run on. So whatever voltage that is times what the run load amp is equals our watts. And then we can calculate our kilowatt usage and total power consumption from there.
Awesome. Yeah. And that's the interesting thing about off-grid electrical systems is it depends on the air conditioner, much like, I would assume, residential is going to run at like 240. You've probably got some industrial applications where your big package units may run at like 208 3-phase or something like that. Off-grid electrical systems are going to be anywhere from 12 volt DC, direct, DC power, all the way up to, there's some 240 volt systems on much bigger RVs, or, a lot of people use like, was it the Mr. Buddy or whatever that is? What's that type of air conditioner? The split.
The Mr. Cool mini
Mr.
splits.
Cool mini splits.
Yeah, mini splits. That's.
I do like Mr. Buddy though. That's a good name.
Yeah, I couldn't remember. It's like I know there's a whole whole what category of those types. But yeah, so that all kinds of different voltages that will be run at on an off-grid electrical system.
Yes.
Yeah, and like on one of those mini splits, you'll have on 2 different data plates. You'll have the run load amps, and so that'll tell you what you need to calculate from there, because you're going to have 2 different power draws.
Yep.
That's great information. Yes.
Yeah, one for the indoor and one for the outdoor. And then kind of going on duty cycle, a lot of environment plays a huge role on what you want your duty cycle to be, like what you want your run time to be. Like if you live in a very arid climate and you're off grid and you don't have any humidity, then your duty cycle doesn't need to be terribly long, because it's not having to remove humidity from the house, or from the off grid, or from the camper, from the RV, whatever it is. And so, and humidity plays a bigger role in comfort level, because if you're in Colorado, you go stand in the shade, it's 10 degrees cooler than it is whenever you're out in the sun. And so keep in mind, environment's going to play a huge role. So if you're in a very humid climate, then you're going to want a system that can have a higher run time that's going to remove that humidity from the house. And then at that point, you're looking at higher efficiency, different types of units that are designed to run longer but draw less electricity. And so those are some factors on duty cycle that need to be considered whenever you're like, because you don't want your duty cycle to be like, the more it runs, the longer it runs, the more humidity it's going to remove, but it's also going to draw electricity at the same time. And so you want something that's going to be efficient to do so.
Do you think we could come to a conclusion for a range of which a duty cycle would be? Maybe 25% duty cycle to 75% duty cycle. Would that be a fair range?
So whenever we're looking at how air conditioners are even just sold across the U.S., and again, I'm speaking purely residential just because there's so much more data on it. We sell air conditioners, all the manufacturers sell air conditioners based on regional zones. And so like we have the Southwest regional zone. And so the Southwest regional zone is New Mexico, Arizona, over to California, and just draw a straight line. The Southeast regional zone is Oklahoma and Texas down to Florida. And then you've got the Northeast and Northwest. And the way they run those is that looks at what percentage of time a system should be running in that particular area. And because the ultimate goal is going to be somewhere in that like 50 to 60% range when when the demand is calling for it.
Yeah.
And there's some really good resources to figure out what that zone as far as runtime is. And so you can look up on governmental, basically EPA and run load times on HVAC systems per zone, and what the expected kilowatt usage is going to be. And you can even do it city by city. So if you're in an RV and you're traveling, you can kind of, and you're like, I'm going to stay in this area for X amount of time. Then you could look at that zone and what that expected outcome.
Yeah, because like especially in an off-grid RV situation, the assumption is that we're moving from one zone to another one. So what you are in one zone might not particularly be the ubiquitous standard by which you judge your power consumption, because you're moving into a separate zone where the humidity might be higher and your unit might need to run longer. Yeah, and so there's a lot of variables coming into play.
And I would say 50% out of the hour would be a good rule of thumb of, okay, we're running long enough to remove humidity. It's not going to be overly consuming power, and we're doing enough to make sure we maintain a comfortable climate in the space.
Yep.
That sounds good. So hopping into question number 2 for Colby, we'll just go in order of age here, youngest to oldest. So Colby, can I just install the biggest air conditioner that I can find so my air conditioner doesn't have to run as long during a duty cycle, which would save me power?
You could. Or you could not. It depends on the goal. So I get this question a lot of time, like because residential homeowners ask the same question. They're like, they want to size the system a certain size, and they're like, is bigger always better? And this is where residential systems are a little bit different than like RVs. Is we have to be very concerned about static pressure, because sometimes the airflow on the ductwork system of how the air is supplied to each room is not sized to handle the largest system that you could possibly get. And so we have to factor in that on the residential side of things. And so if you're living in off-grid home, like that's a factor. Like you want to make sure that the ductwork is sized correctly for that unit. And so, but for installing the biggest system, it kind of goes back to duty cycle. It goes back to runtime. So like you can get the biggest thing that you want to. It technically cool the house down to your ideal temperature, but you're also going to have like dew on the windows because the humidity level is going to be just outrageously high. You're going to have dew coming off the vents. You're going to have humidity or condensation coming off of your, it could be your mini split, it could be your component, and so that is a factor. Whereas like if the biggest system's it's going to provide a ton of cooling capacity, but the problem is if it's not running long enough, you're going to have way too much humidity in that facility to be comfortable. Because everybody, like I kind of mentioned earlier on the duty cycle and runtime, is going and standing in the shade in a very arid climate is very different than going and standing in the shade in a very humid climate. And so it takes the heat. Like it takes the heat with you. So like you go stand in the shade, it's the same temperature. But in arid climates, it's the opposite. So I would never size a system to be the biggest thing that I could possibly be on the home simply for that reason. And also too, energy consumption. And you also have to take in consideration that every single time that unit starts, it's like starting an engine. What is the worst time to ever start? What is the worst part of a engine's life?
Yeah, that's that startup process.
It's that startup. And so if you have a big unit, a big system, it's going to cool off so fast. You're going to have a lot of cycles within its lifespan. And so you're going to have a lot of startups. You're going to have a lot of just stress and wear from that system turning on and turning off more frequently than you would if you had a system that was sized correctly that would run for the right amount of time. Mm-hmm. And so, because you want that system to run to cycle the oils that are in that compressor, you want it to run long enough where everything is working efficiently as far as kilowatt usage, energy consumption. You want that compressor to run long enough to cycle the oil, to cycle the pressures, and then whenever it shuts off, it's a lot easier whenever you've got the frequency of how many times it shuts on and off is significantly less. And so there is no benefit to sizing the system as large as you possibly can to cool the house down fast or the RV down fast, because it's just the amount of problems that you're going to have because of it being oversized is just way too great. And so,
can I jump in real quick? So something too that like a rule of thumb that I use on a lot of my residential calls. Now this applies to residential and our specific quadrant that we're in. But if you've got a house, a good rule of thumb is if you take the square footage of the house and divide that number by 400, that gives you the approximate size of air conditioner or AC that you need to adequately cool that space. Now that 400 assumes a couple things. It assumes pretty decent insulation, it assumes some pretty decent windows, and just a pretty decent insulation in your walls as well. Yep. And so, but if you take that and you divide that square footage by 400, right, you're going to get roughly about the size of air conditioner you need to condition that space. Well, that also assumes you don't have a large roof pitch because we're not conditioning a 2-dimensional flat sheet of paper. It's a 3-dimensional space. So if you've got like a really big living room or something like that, it's going to take more cooling capacity in order to cool that room.
It's kind of like shirt sizes, guys. I could wear a small or I could wear a 6X, but I need to wear the right size shirt.
Yes.
Yeah. You could.
You're going to get
Or
a
you
different
could
look
not.
either way.
You could, but should you?
Okay, going to fix video real quick. So those are really good points, and I think something that is worth mentioning. If you get an air conditioner that's twice the capacity, it's going to be twice as powerful, but you're running it half as long. Like the energy consumption is going to basically level it out. If you have it, it's not really going to matter from a just trying to save power standpoint. And even so, the more powerful air conditioner is going to take a bigger inverter to power it. And so like the startup amps that it's going to take, you're going to need the off-grid inverter to be able to support that. Whereas if you just size something that's going to have a proper duty cycle, that's not going to be as much of an issue.
Yep. And if you take that, a really easy reading is if you have a voltmeter and you just put on the electrical components whenever that compressor kicks on, the amp draw at the very beginning of that startup is going to be significantly higher than the run load amps that it's going to have. And so it's like, okay, well, it's twice as big. It's going to run. It's it's going to cool very, very quickly, but it's also going to turn on. Like the frequency is going to double because it's going to turn on and off, turn on and off, turn on and off. And so you're going to have more amp draw spikes because of that. And so as far as an energy consumption side, yes, wear and tear for sure, but energy consumption and efficiency, it's kind of moot. It doesn't make sense to oversize the shirt, so to speak.
Perfect. I think that's great considerations there. All right, let's move on to the last question we've got here. Over to William there in the back. All right, question number 3. Does the physical size of a unit, so actual physical dimensions, does it correlate to efficiency? AKA, does more cooling BTUs always equal more power needed? And the context of this question is, on boats and RVs specifically, sometimes we're limited on the amount of like physical footprint that we have available to us to install these things. And the question is, is there a more efficient air conditioner that's smaller?
So yes, but it kind of, so I answer this question by kind of explaining how air conditioning works, and that will inform kind of how this question's answered. So way air conditioning works, and I'm going to explain it maybe a little bit too simply, but just for succinctness. As your blower's pulling air across that evaporator coil is got refrigerant running through that, right? So that refrigerant's really good at absorbing heat. So as that refrigerant absorbs the heat, it brings it to the condenser, where the condenser compresses the refrigerant, right? So it boils that refrigerant off, right? Condenses it back down into a liquid to send it back to the compressor. So what you feel on the receiving end of things is on the other side of the evaporator coil is air that has had the heat removed from it, right? But in order to increase efficiency, right, you've got to have so much space on the condenser side where the refrigerant is boiling off. So yes, if you increase the physical size of the unit to where you're boiling off the refrigerant fast enough, right, you're going to have a more efficient use of that energy. But it goes back to what Colby and Tucker were saying, was if you oversize your system, right, then you're going to have other problems as well. And so it really just kind of depends on that space. But a simple answer, if you can have a really large unit, a big physical footprint, you're going to have, it might lead to a little bit more efficiency, but you're going to have the trade-off of other problems that are going to outweigh some of that other stuff as well. And
the physical size of a unit, like if you have a 2-ton unit, there's going to be varying sizes. Mm-hmm. And more often than not, if it's a larger footprint 2-ton, it is going to be more efficient because the more surface area we have to boil off refrigerant and allow it to condense and cool down, the more efficient that system is going to run.
So like I explain it to homeowners like this too. So if we've got like an X and Y axis, and on this X axis we have all the tonnages, right? So 1 ton, 2 ton, 3 ton, 4 ton, 5 ton. And then over here on the Y axis we have our efficiencies, right? So in each you've got different levels of efficiency. So you've got a single stage, 2-stage variable. Now on an off-grid system, an RV and a boat and all that kind of stuff, it might be a little bit different than this, but this applies to a residential application. You've got, you might have a 2-ton right over here, but then your single stage 2-ton and your variable speed 2-ton, those might be two different sizes, right? In order to achieve that efficiency. So that kind of informs a little bit of my answer is like, yes, the physical size does matter, but you also have to size it appropriately to the space. You can't just have like a skyscraper of a condenser outside.
Yeah, those are great. Oh, wow. Audio, video. There it is. Oh, hey, we're back. I didn't have to do anything. So those are great points. And I was talking to, Nomadic Air Conditioning, they make air conditioners for RVs, DC air conditioners specifically. And, he was talking to me about that one day and was saying, it's like, there's only so much cooling capacity you can put on a camper van roof just because of, you're limited on, how tall you can make the actual unit. And he's like, you can't be going down the road just like what you said with a skyscraper of a condenser, sticking up above your air conditioner. Plus, the weight, you're having to, all these rooftop air conditioners live on the roof of a van. And, the more weight you get up on the roof, the more top heavy it's going to be, the worse it's going to handle, potentially being dangerous going down the road. Off-grid cabins, probably less of a consideration on the physical footprint. I think people with off-grid cabins usually have a lot more space to be installing stuff. Maybe, tiny houses might be an exception there, but yeah, those are great points. So I think we can probably start wrapping it up. We got a ton of information. Is there anything additional that we didn't really touch on that you guys feel is important for people when they are thinking about, the electrical power consumption of various air conditioners?
I think we kind of touched on a lot of the key points of like what people need to be looking for and considering when moving, or not moving, but selecting an air conditioner for whatever application they're trying to put it in. And so I think just looking at the tonnage and how that correlates to the space you're trying to condition, and then the type of unit that you're getting. Is it a single stage unit, variable, and all that kind of stuff.
So, Nate, I've got a question for you. You might be able to provide a little bit more insight on RVs. I guess specifically RVs. My assumption is that the majority of like off-grid would be running off of DC. For the most part, you would have variable capacity systems on these campers, RVs. Is that true?
It depends on the air conditioner in particular. There are air conditioners that, like the Nomadic DC air conditioner that we have on our van. It's got two to three different levels. It's got like, it's high powered mode, and then it's got like an eco mode. And that eco mode, it uses half the amount of amps as the high powered.
So it'd probably
So
be
it'd be
a
like a
two-stage.
two-stage.
Yeah. So I guess my next question would be is like, do you feel like in your realm of off-grid, are people educated on the different types of systems? Like, do they know what variable capacity, like do they know how a variable capacity system works? Do they know how the two-stage system works, and do they know that versus a single stage?
I would be saying that that air conditioners is very much like the Wild West in RVs, because like even a lot of the air conditioners that come pre-installed from the factory, there's really, like on air conditioners for residential units, they have to be a certain efficiency rating for you guys to even install them, right? And that's, I mean, to my knowledge, that's not a thing in RVs. So you could have like a 6-SEER RV or whatever, and it's just going to be incredibly inefficient. But, since RV manufacturers are allowed to do it, it's cheap and they're going to do it. So, there's a shift happening in off-grid like mobile air conditioners and stuff like that. You do have companies who are coming in and starting to say, hey, like we can make something a little more efficient. It's going to be a little more expensive, but you're going to get a better end product like that Nomadic air conditioner where it is two-stage, where you've got a high power mode. And then, whenever you just need a little bit of cooling, you can kick it down into a half power mode kind of thing. But I think that all of that is fairly new. And so, no, I think the education is not quite there about that.
Okay.
Yeah.
So I guess in short, if you are someone that is looking at these different kind of technologies and like what to consider, that might be a really good topic to kind of go over real quick. So in layman's terms, so like your single stage system, easy way to understand it, it's like a light switch. It's on, it's off. It's on, it's off. It's
either 0 or 100.
0 or 100. Your two-stage system, which kind of talks about your half speed, where it goes, drops down to 50% consumption. That's going to be what we would in the residential world, a two-stage system. And so it's gonna utilize it's gonna run longer on that half power. That's gonna help remove more humidity from the house. The duty cycle is gonna be extended, but you're using less electricity for that two-stage system to operate. And so hence the half power mode. On variable capacity systems, and this is true for residential homes, it's like having, we have one stage for single stage systems, two stage for two stage systems. For variable capacity, it's like on residential, it's like having 700 stages of cooling. So a lot of times variable capacity systems will run on the lowest stage, removing a ton of humidity from the house, and the run cycles, like it may not shut off, but the power consumption is going to be a third of what it would be at full power. And it kind of depends on if it's 80 degrees outside, really nice, you're in an arid climate, you don't have a ton of humidity, it's going to stay on that lower power.
Yeah, it might
power
run.
consumption.
It might run for hours on end.
Yes.
Yeah.
But it's pulling next to nothing.
Yes. Yeah. And in comparison to like windows, like for example, on everybody is kind of familiar with window units, how much amps they pull. You're going to be close to 10. We'll just say roughly 10 amps for a window unit. A variable capacity system, and it can be up to a 4-ton, 5-ton, a big system enough to heat and cool in Oklahoma. 2,500 square foot space. It might be running at like 7 amps.
Wow, that's pretty incredible. And I would say the variable systems like that are. Somebody's going to correct me down in the comment section, but I don't think I've ever seen one for like a rooftop air conditioner.
Yeah,
And that's what I was going to point out
Yeah.
is in your rooftop air conditioners for like campers, vans, and like that. That's not going to be really an option. But for like your boats and for your off-grid cabins, those are where you can get into some variable capacity stuff.
Yeah.
That it's like that Mr. Cool that we were talking about.
Yeah.
You can get into some variable capacity stuff that's super efficient and will just sit there and limp along and not pull anything, but keep the space dehumidified and comfortable.
Yeah.
Another, on top of what Tucker was saying too, we were talking about duty cycle and runtime and whatnot. One thing that's also nice about the variable capacity systems is the ability to help also improve your indoor air quality. So like you're living off grid, you're somewhere, you're tracking dirt, debris inside the house, you're going in, at least that would be my assumption. A system that runs longer is going to help remove, like if the proper filter system, when that system is running longer, it's going to catch more of that debris in the filter system. So it's going to be a lot more efficient at keeping your air quality maintained within the home whenever you're going in and out. And so not only does it help remove humidity from the house, it also helps remove all the dust and particles that are brought in from your day-to-day.
But Nate, as you can tell, we could talk about this all day long. This is what we do. So
We do talk about this all day long.
Well, I think that pretty much will wrap that up. If anybody has any questions for any of these guys, just leave them down in the comment section below this video. We're going to let them go. They've got more work to do today. Also, if you guys want to hear these guys talk about some stuff in the service industry, air conditioning service industry, they've got a podcast that I'll link to below, the Blue Collar Bros, a play on words for our last name of Yarbrough. And it's great. There's 4 episodes, and they've promised me that they're going to be putting out more eventually.
We're recording this Saturday.
Hey, outstanding.
in perpetuity, this Saturday.
Yeah, this
Whenever.
Saturday. Yeah. Whenever this comes out.
Well, guys, thank you so much for taking some time out of your day. We're going to let you go, and I'm going to hop back over into teacher mode, and we're going to try to summarize up everything that you guys have told us into some actionable steps so that people can figure out what size of air conditioners they want to install and how much power they can expect from them. Will, Colby, Tucker, thanks for your time today. We'll see y'all later.
Thanks. Good to see you.
See ya.
Now that we're all experts in air conditioner power consumption, let's put that new knowledge to use. For our example, we're going to be using the Nomadic 24-volt X3 DC air conditioner, which is the newer model that we personally have on the explorist.life show van that we built 2 years ago. And right on the product page, it lists the max wattage as 1300 watts, which is consistent with its 55 amp rating in max mode, since 55 amps times 24 volts equals 1320 watts. Now, since we understand that the duty cycle of an air conditioner should be an average of, call it 50%, we can say that the air conditioner is going to use 1300 watts for 50% of every hour that it's actually on. So 1300 watts times 50% times 1 hour equals 650 watt hours. Now, if we had this air conditioner running for 6 hours, this would be 1300 watts times 50% duty cycle times 6 hours, which is 3900 watt hours. And since this is a 2-stage air conditioner, like Colby mentioned in the interview, with a low or eco mode, as Nomadic calls it, it can also operate at 30 amps, which is 30 amps times 24 volts equals 720 watts. And then the math from there would just be the same, just substituted with 720 watts. 720 watts times 50% duty cycle times 6 hours of air conditioner usage on eco mode equals 2160 watt hours. And that's how we find our answer. How much solar is required for air conditioning? Since air conditioning is most needed during the daylight hours, we can utilize solar to offset battery drain. And here's the easiest way to think about that. If your solar panels are producing as many watts as your air conditioner is using, you can realistically run your air conditioner as long as you want, given this guideline. So, a 1300 watt air conditioner running at a 50% duty cycle would require an average of 650 watts of actual power output from the solar panels to keep up. But keep in mind that solar panels may not put out their rated wattage during the hot summer months, as solar panel efficiency decreases as their cell temperature rises, and you may need more than 650 watts of solar panels to actually harvest 650 watts of solar power. And also keep in mind that you'll need enough solar to recharge whatever was used overnight the previous night from other loads. Now, before we move on, I want to hear from you. After watching this video, I would love for you to test out your own air conditioner and put the results down in the comment section below. Let me know the wattage, the observed duty cycle percentage, how many hours you use it during a normal day, and any other usage habits, and then let me know the daily watt-hour results you get from your calculations. I'm trying to build out a database of what kind of power usage various devices use, and teamwork makes the dream work here, so help me out and let me know down in the comment section below. How much power for overnight air conditioning? Now, if you are unfortunate enough to be vacationing in South Texas in August, where it's 90 degrees and 90% humidity overnight, you're going to need a very large battery bank to support overnight air conditioner usage. 1300 watts times 50% duty cycle times 12 hours of darkness equals 7,800 watt hours. And for perspective, 7,800 watt hours is about 650 amp hours worth of 12 volt batteries just to run the air conditioner overnight with no other loads. Now, all of this is assuming a 50% duty cycle, and if that increases due to extremely hot weather, so will the energy consumption. Now, if you don't have the budget for a solar-powered battery bank large enough to support air conditioner usage, remember that a backup fuel-burning generator or high-powered alternator charging is always an option when you can't drive to cooler locations. Now you should have a good idea of how to calculate the power used by an air conditioner in a mobile, marine, or off-grid electrical system. And we will be referring back to this video later in this academy when we discuss full power audits, so be sure to bookmark it for future reference and come back to it if you need a refresher. And in the next lesson, I'm going to teach you how to determine the power required for LED lights, so click up here to watch, and I'll see you over there.